So can you once slide up?
Okay.
Thank you, sir.
Read the question. No? The coil is telling, and there's a solenoid is there, and the current through the solenoid. Calculate the magnitude of induced current in the 1500 ton coil. Neglect self-inductance of the coil. That also he has put one condition. And what is the magnetic field produced by the solenoid? Mu naught Ni. Is that okay? No. So this is then solenoid with 240 turns and radius of 4 centimeter. How do we can bring solenoid? Where is the coil? I think this is a coil. Huh? So when B bar varies, that B bar will link the solenoid. The B bar produced by solenoid will link the coil. So what is this I'll call B1. Flux linking the coil should be equal to B1 into radius of the solenoid only. So I think I'll give one small diagram at least. Radius of solenoid is this much and the coil is this one. Radius of solenoid is R. Radius of the coil, let it be C. What all the solenoid? Here the current I1 flows. Already I think yesterday's class I discussed. So here B bar will be like this. Over the flux linking the coil, B1 into effective area pi R square only, not pi A square. So this should be equal to mu naught number of turns of solenoid, number of turns per centimeter. Okay, that is N1. N1 into pi R square. This is what flux linking the coil. But how many turns the coil is there? 1500 turns. So shall we put N2 here? This is what flux linking one turn of the coil. Flux linking N2 number of turns of the coil. That is N2. Mu naught N1 I1 pi R square. Keep it here this much. So now when the current changes from 0 to 20 ampere in 10 seconds, then what is the flux? It will change. So delta phi 2 should be equal to N1 pi R square. So current will be 20 minus 0 by 0.1 second. This will get EMF into. So what is the current now? Current should be I2 should be equal to E2 by the resistance of the coil. 5 ampere will come, check it. Do calculation later on. So